1999 Canadian Open Mathematics Challenge, Part B. Two identical triangles each have an area of 24. Their vertices are determined by the intersection of the lines y equals -4, x equals 0, and y equals -3/4x plus b. Determine the two possible values of b. And then part B, for either of the two given triangles, a circle can be drawn to pass through its three vertices. What is the radius of the circle? Well, we don't need to be Rembrandt here. Just a basic diagram will suffice. Let's just draw this triangle. X equals 0. Well, x equals 0 is this line right here. The y-axis is x equals 0. Right? Because y can be anything, but x can only be 0. Y equals 4, or -4, I should say, is somewhere here. If this is -4 down there, y equals -4. And then we have this one, which is not as straightforward. Y is equal to -3/4 x plus b. Okay? Well, when x is 0, y would be b. Now, we don't know what b is, so I'm just going to say b is up here somewhere. I don't know. So I just have to go with what I know, which is b is on the y-axis. And when y is 0, we'll figure out what is the value for x in terms of b. 3/4x is b, and therefore x is equal to 4b/3. All right, so wherever 4b/3 is, again, I don't know, but let's say it's somewhere here. So now, if we draw that line, it'll be something like this. So there we go. There's our triangle. And this is the triangle right here. I'll just draw it in red. This is the triangle. Now, they're saying that this triangle has an area of 24. So 24 is equal to 1/2 base times height. Right? That's the area formula for a triangle. The base is here. This is the base, and this is the height. Well, the height is probably the easier one. It's going to be, well, from here to here is b, from here to here is 4 in terms of a positive distance. So the height is b plus 4. That's the easy part. The base is a little bit more tricky because we have to figure out the coordinates of this guy right here. That's not that big of a deal. It's basically an intersection of y equals -4 and this line. So y equals -4, so we just substitute that in to that line, and that should give us a value for x in terms of b. So 3/4x is equal to b plus 4. So therefore x is equal to 4/3 times b plus 4. So this point right here is 4/3 b plus 4. And the y coordinate is -4. So we substitute that back into here. So this distance right here, which is the base of that triangle, is 4/3 b plus 4. And then I think this will be sufficient to solve for b. Let's see here. We got b plus 4, two of them, so that'll be b plus 4 squared. And then this will be 4/6. So if I cross multiply, it'll be 6/4 times 24. So 24 divided by 4 is 6. 6 times 6 is 36. And then expand this out, b squared plus 8b plus 16. Put it all on one side, you get b squared plus 8b is -20. And that factors really nicely into b 10 to positive negative. So b is either -10 or +2. And that is the solution for part A. Okay, now let's go to part B. So now they're saying they're going to draw this circle, and that circle is going to basically be like that, where it's the vertices of the triangle are on that circle. So right here, and right here, those are the vertices, correct? And then they want you to figure out the radius of that circle. Okay, well, how do you do that? Well, here's the key to that question is that, notice right here, that's a right angle, correct? Because this is the y-axis, and this is the line y equals -4. And those are obviously perpendicular to each other, so therefore that's a right angle. And there's the rule that if you draw a triangle inside a circle, and that triangle creates a right angle, then that must mean that this line is the diameter of the circle. So that means it makes it pretty easy for us that we can just figure out the length of that diameter and then divide it by 2 to get the radius. How do you figure out the length of the diameter? Well, you just have to figure out the length of this line. And if we have both points, we can. This point over here is 4 over 3 b plus 4 -4. And we just figured out that b was either -10 or 2. You can use either one. I'll use 2. I'll use b equals 2. And that will be what? 2 plus 4 is 6. 6 times 4 is 24. 24 divided by 3 is 8. So this is 8 -4. This point right here. Okay, now let's figure out that point. That point is, the x-coordinate is 0, and the y-coordinate is b. Well, b is 2. So there we go. These are the 2 points. I just have to figure out the distance between those 2 points. That will be the diameter. And then to get the radius, you divide by 2. All right, so the distance formula for those two would be 8 minus 0 squared plus -4 minus 2 squared. And that is the diameter of the circle. And of course, you have to take the square root. This is 64. This is -6 squared, 36. This is 100 square root, which is 10. Well, diameter is equal to 2 times the radius. So the radius is 10 divided by 2, which is 5. If BD plus CD is an odd integer, show that the cubic polynomial x to the power of 3 plus bx squared plus cx plus d cannot be expressed in the form x plus r times x squared plus px plus q, where b, c, d, r, p, and q are all integers. So we will say that our original assumption is that this cubic polynomial can be expressed in that form, and then we will later show that that is not possible. And when you show it's not possible, then our original assumption will be wrong, and that proves that it cannot be expressed. So it's sort of like the proving by contradiction or whatever. All right, so here we go. X squared plus px plus q. So I'm saying that this can be proven, this can be done, that this can be equal to that, given our conditions, that this is an odd integer. All right, so the first step, of course, is going to expand this thing out and compare like terms. So when we expand it out, we get x to the power of 3 plus px squared plus qx plus rx squared plus rpx plus rq. When I collect like terms, x to the power of 3 just has one term, and then x squared, that has, what's the coefficient there? P plus q? P plus r. Yeah, p plus r. And then the x has as a coefficient q plus rp. And then there's just a, is there anything? Yeah, just rq at the end. Okay. Now let's compare the coefficients. This is 1, this is 1. Okay, well, that matches. This is b, and this is p plus r. So that must mean that p plus r is equal to b. So that's our first equation, right? I just matched coefficients. This coefficient is c. This coefficient is q plus rp. So that means that q plus rp is equal to c. And then finally, this lone d is equal to that. So rq, I believe. Yeah, rq is equal to D. And that's our third equation. All right, so far, hopefully that isn't too complicated. Now, we have to concentrate on this statement right there, that BD plus CD is an odd integer. So, BD plus CD is odd. An odd integer. All right, so we can factor out a D, and when you do, you get B plus C. Now, this is an odd integer. Now, I'm going to use some numbers here because it'll help. So let's say I have, this is odd, right? This whole thing is odd, but it's a product. Let's say I have an odd number. Let's say it's 21. 21 is expressed as 3 times 7, correct? Notice 3 and 7 are both odd. If you don't believe me, let's try another one. Let's try 15. That's an odd number. That's 3 times 5. 3 and 5 are both odd. You get the point here? So the point I'm trying to make is that this is odd, just the D by itself, and this is also odd, just B plus C by itself. And I hope those two examples prove to you that that is true. Okay, so D is odd. That is a conclusion that we are pretty confident about. And then now what we will do is we will look at these three equations and kind of work with that. So let's look at this one here. RQ is equal to D. D, we have just concluded, is odd. So that means R times Q is also odd. But I conclude that both of these are odd individually. For example, if I have, let's say, if D was, say, 35, which is an odd number, 35 is what? 5 times 7? Notice both 5 and 7 are odd. That's why I concluded that R is odd individually and Q is odd individually. All right? Okay. So far so good. Hopefully there's nothing confusing there. Okay. Now let's get into these guys here. This whole B plus C stuff. The B plus C, which is this guy right here. B plus C, we have concluded up there that it was odd. Correct? All right. Well, B plus C, this is B and this is C. So let's put those guys in. B is P plus R and C is Q plus RP. Okay, well that means this whole thing must be odd. Right? Okay, well, we can factor out a P. And here we're going to have R plus Q, but then we can factor out a P, and when we do, we get 1 plus R. And that's about as far as we can go there. Now, over here, I had concluded that R was odd individually, and Q was odd individually also. So if you add them together, they will be even. R plus Q will be even. For example, if R was 5 and Q was 7, 5 plus 7 is 12, which is an even number. So that means that this is even, R plus Q. All right, following me so far? And remember, this was odd. Now, this is odd. This is even. This must, therefore, be odd. Must be odd. Because the only way you can get an odd is to add an even with an odd, correct? Because if this was even, then it would be even plus even, which is even. Correct? All right. So that means P times 1 plus R must be odd. But here's the problem. This is not possible. Why? Why is it not possible for it to be odd? Well, the reason is because R, this guy right here, is odd. R is odd. So because R is odd. If you add 1 to R, which is what we're doing here, r plus 1 will be even. And if r plus 1 is even, then r plus 1 times p, regardless of what p is, will also be even. So therefore, p times 1 plus r will also be even. So therefore, it cannot be odd. So that means that there's no way for this to all work. Everything that we did here falls apart. And hopefully you see why. And that's really all this question was, sort of playing around with odd and even numbers. So this implies that our original assumption is incorrect. Therefore, that polynomial x to the power 3 plus bx squared plus cx plus d cannot be equal to x plus r times x squared plus px plus q with the given conditions in the question stem. And that's pretty much it. Triangle ABC is a right-angled triangle with its right angle at A. The points P and Q are on the hypotenuse BC such that BP is equal to PQ is equal to QC, AP is 3, and AQ is 4. Determine the length of each side of triangle ABC. Let's label this. Well, 3 and 4 are already labeled. They're saying that BP is equal to PQ is equal to QC. So BP is equal to PQ is equal to QC. Okay. I'll just call those X in terms of a length. This side, just call it Y, and this side, might as well just call it Z. So there we go. Got it all labeled. Okay, so now where do we go from here? Now we have to use a cosine law, I'm pretty sure here. It really screams cosine law. Yeah. And I think because it's a right angle, it'd be very easy to figure out the cos of B or the cos of C, this angle and this angle. Okay, I think that's pretty good way of approaching it. So let's try first the triangle ABP cosine law. So ABP, I'm going to use this angle, angle B. So 3 squared is equal to x squared plus y squared minus 2xy cos of angle B. And that means 9 is equal to x squared plus y squared and minus 2xy cos of B. But cos of B we can figure out pretty easily. Cos of B is adjacent over hypotenuse, right? And it's a right triangle. This big guy is a right triangle. So adjacent over hypotenuse, adjacent in this case is y, and hypotenuse of the big guy is 3x. So y over 3x is what goes into cos of B. So this is just 9 is equal to x squared plus y squared minus 2 over 3. The x's cancel and we just have y squared. And that is about as far as I can go. That's equation 1. All right, great. Now let's look at another triangle, triangle ACQ. ACQ, this guy right here. And same thing, cosine law again. And let's see here what we get. 4 squared this time is equal to x squared plus z squared minus 2xz cos of C. Cos of C we can get pretty easily. it would be, again, adjacent over hypotenuse, which is z over 3x, right? You're looking at the big triangle, the big one right there. So this is 16, x squared plus z squared minus 2xz, z over 3x. This is 16 is x squared plus z squared minus 2 over 3 z squared, because the x's cancel. And this is my equation number 2. Okay, pretty good, I think, so far. Now where do we go from here? We have, we've got 2 equations, but we got 3 variables. That's a problem. We need one more equation. The third equation we get from Pythagoras, because it's a right triangle. That's an easy one. I'll put it down here. That would be y squared plus z squared is equal to 3x all squared. That's my third equation. Okay, I got it. Okay, no problem at this point. 3 equations, 3 variables we can solve. So whichever way you want to do this, what I'll do is I'll add 1 plus 2, equation 1 and equation 2. When I do, I get 25 on that side, and on this side I get 2x squared plus, actually, this can be simplified, right? Because 1 minus 2/3 is 1/3. So this is just 1/3 y squared. And same thing here. This can be x squared plus 1/3 z squared. Yeah, that makes it easier. So if I'm adding, I'm just going to have y squared plus z squared all over 3. Okay, that's really good, because y squared plus z squared I have right there. So 25 is equal to 2x squared. Y squared plus z squared is 3x squared, which is 9x squared over 3. Great. So 25 is equal to 2x squared plus 3x squared. That's 5x squared is 25. X squared is therefore 5, and therefore x is root 5. And now we can easily figure out the values of the other guys. What are my dimensions here? 3x. Yeah, 3x. BC is 3x. AB is y, and AC is z. Okay. So BC is 3x. So that one I already got. That's 3 root 5. AB I had designated as y. I can figure that out. And AC is z, and we can figure that out also. All I have to do is just sub these values back into these guys here. So I got x, so I can easily put it back into this equation to get y. 9 is equal to x squared plus y squared over 3. 9 is equal to x squared is 5. Y squared over 3. So y squared over 3 is 4. That means 12 is y squared, and therefore y is root 12. So y is root 12. There you go. That's AB. And then the last one is z. I can just put it into this equation, I guess. So 16 is equal to x squared plus z squared over 3. 16 is equal to 5 plus z squared over 3. 11 is equal to z squared over 3. So z squared is equal to 33. Z is therefore equal to root of 33. And there you have it. Those are the lengths of the 3 sides of the triangle. Triangle ABC is any one of the set of triangles having base BC equal to A and height from A to BC equal to H, with H less than the root 3 over 2A times A. P is a point inside the triangle such that the value of angle PAB is equal to the angle PBA is equal to angle PCB is equal to alpha. Show that the measure of alpha is the same for every triangle in the set. All right, let's draw a diagram and let's go with that. So here is a triangle. I just call it ABC as they do in the question. And then let's talk about this. This triangle, obviously BC I have made the base, so they're saying that's equal to A. Now they're drawing a line A down to BC, so they're drawing a line like that, and they're saying that that is equal to H. Okay, let's just put that on the side there. That altitude is H. I don't want to make the diagram too messy here because I got to put a P in there. And then they're putting this P somewhere. I'm not sure where, but let's just say here. And they're saying that when you connect these, B to P, P to C, and A to P, that the angles are all going to be the same. So PAB, this angle, which they have said is alpha, is going to be the same as PBA. PBA is alpha here. And PCB, so alpha here. Okay. PAB, PBA, and PCB. All right. So where do we go from here? Okay. Well, I'm going to put one more angle, and that angle is this whole angle right here, from there to there, that entire angle. I'm going to call that beta. So therefore, this angle in here is obviously beta minus alpha. Correct? And this angle here is going to be 180 minus beta. And the reason is because if that angle was, let's say, angle, whatever you want to call it, theta, and I didn't know what it was, we know that theta plus alpha plus beta minus alpha is 180, right? The properties of angles of a triangle. And then when you solve for this, you get that theta is equal to 180 minus beta. And that's why I wrote 180 minus beta. I had just done it in my head. Okay, I think we're done with labeling. Now we move into the part of the question that solves this. And we're going to use the sine law. So first, on triangle PBC, we will use the sine law. So the sine law using triangle PBC, this guy down here, this triangle, we have PB over the sine of alpha is equal to A over the sine of 180 minus beta. Correct? And that is, well, sine of 180 minus beta is the same as sine of beta. That's one of those trig properties. So I can just put that in there. This is equivalent. These two are equivalent. Okay, so PB is equal to, PB over sine of alpha is equal to A over sine of beta. And if I put the PB, if I isolate for it, and I bring the sine of alpha up top, then I get this. A times sine of alpha over sine of beta. Okay, so this is my equation number 1. Now I will do something very similar, but on a different triangle, triangle BP. Let's see, which triangle can I use here? I'm going to actually draw a perpendicular here, like that. And this point, I'm going to call N right there, the point where it touches. And one thing you'll notice that's very interesting about this is that this is actually an isosceles triangle, this one right here, APB. And I say, well, how do you know it's isosceles? Well, because look, these angles are the same. They gave you that in the question. So that means if those are the same, that means it's isosceles, and that means this is the same as that. That PA, that distance is the same as PB. Okay, so now let's go back to what we were trying to do before. I'm going to use triangle BPN. BPN, this guy right here. So this is a right angle, correct? Because that was a perpendicular right there. So in triangle BPN, we can figure out that the cos of alpha is, as always, adjacent over hypotenuse. So adjacent is BN, and hypotenuse in that case is BP, or PB. Doesn't really matter how you write it. Now BN, there's a property that in an isosceles triangle, if you draw a perpendicular, it cuts the base into half. So that means that this BN is equal to NA. So BN is really just AB divided by 2. And that's over PB. All right. And then we can isolate for PB. This is cos alpha. So that means that PB is equal to AB over 2 cos of alpha. All right, so this is equation number 2. Let's move this up. Now PB is equal to this, PB is equal to this. That means those two must be equal to each other. So that means AB over 2 cos of alpha is equal to A sine alpha over sine beta. If we cross multiply, we get 2 sine alpha cos alpha. And on this side, we'd have AB sine of beta over A. Well, this, from our trig identities, is the sine of 2 alpha. But this, we have to try to figure out a relationship. If I draw that original triangle again, remember this is A, this is B, this was the height given as h in the question. We had denoted this as beta. We can figure out the sine of beta, this guy right here. It's going to be h over AB. So AB times sine of beta is h. So this numerator is just h, so that becomes this h over A. But they gave us in the question that h is less than root 3 over 2 times A. So if the sine of 2 alpha is equal to h over A, and h is less than root 3 over 2a, according to the question, then that means that the sine of 2 alpha is going to be less than root 3 over 2a. You can just substitute that for h. And then, of course, that's all over a. The a's cancel, and you're left with sine of 2 alpha is less than root 3 over 2. Okay, so using our knowledge of the sine graph, do they give us any parameters in the question? They don't, but we know that alpha's got to be pretty small since it's part of a triangle. It can't be like 500 or whatever. And the three angles of a triangle always add up to 180, so alpha's got to be less than 180. So we can tell from this right here that 2 alpha is less than 60 degrees, pi over 3, because if sine of something is root 3 over 2, then that is going to be equivalent to 60 degrees. You can verify that. So, for example, if this is 0 and this is 180, 60 degrees is approximately here, right? Yeah, approximately. So, sine of 2 alpha is less than pi over 3, therefore alpha is less than pi over 6. So, what does this conclude? It concludes that the alpha, the angle, is always going to be less than pi over 6 regardless of what a and h are. So we can conclude that the angle alpha is the same for any given value of a and h. and therefore that means there's only one value for alpha. And I think that's what the question's asking, right? Show that the measure of alpha is the same for every triangle in the set. Right, so it's always going to be less than pi over 6, regardless of what h or a were, because those sort of, it doesn't really matter, it seems. It always ends up giving you this, because the a's cancel, and the h, once you substitute it, it ends up giving us this result. And that's the solution for number 4.